Hey everyone, my name is Mike, and I'm going to give a quick introduction to Zeebe, just in case anyone in the room isn't too familiar with it, you haven't had a chance to check it out yourself. It's going to take a few minutes so that we can get to the live hacking as promised. And so if you go to the Zeebe website, zeebe.io, you'll see that we call Zeebe a workflow engine for microservices orchestration. Been working on Zeebe for about a year now. We're developing it in the open source, so you can download a preview version if you'd like, get hands-on with it. And talk a little bit more about the use case. Of course, we touched on this in the keynote this morning, but that was 4 hours ago. It was pretty early, so show you this graph again, where we ran a survey, asked people in the Camunda universe how they were building microservices architectures, the problems they were running into. And the two challenges that showed up most frequently were, of course, lack of visibility into processes that span multiple microservices, and then ambiguous error handling, especially when an error takes place at the boundary of two or more microservices. And again, we go outside of our Camunda world and look to some of the companies who are the first to adopt microservices architectures. We mentioned Netflix this morning. There are others such as Uber and Airbnb and ING who have all sort of come to the same conclusion independently that, hey, some sort of orchestration layer is super important when you're building a microservices architecture. And these are companies who open source the frameworks or the engines that they built for their own purposes, have talked about them at conferences and things like that. So it's nice, like validation for us. This isn't just an idea that exists in our head, something we made up. And so it seems like it's a real problem. And of course, we already have a lot of Camunda users building orchestration solutions with Camunda BPM. And so the last version released the end of May, 7.9, included a new feature, external task clients, to make it even easier to support this pattern. And we also know that Camunda BPM is pretty capable from a performance standpoint. So there's this research paper that we really like. It was written a couple of years ago. Some professors in Europe compared different workflow engines from a performance standpoint. And we like it because it says things like this: Camunda performed better, was more stable than Workflow Engine A, Workflow Engine B. So we're at this place where, okay, we have some features in Camunda BPM that make it easy to support the orchestration pattern. We know that Camunda BPM is pretty solid performance-wise, so why do we think about Zeebe? Why do we think about sort of a new workflow engine for a different type of use case? And the answer is, or I guess the next question rather, is what do we do when we have a use case that requires 1 million new workflow instances started per second, for example? So this is another chart that you've seen in some form, I think, at the conference already, but we have what sort of the public perception of workflow automation is: relatively low latency, low frequency use cases. These people aren't at CamundaCon, so they don't know what we know, which is that workflow automation is actually capable of a lot more than that. And we're doing at a more high level when we think about Zeebe is wondering how we can extend workflow automation to a whole new set of use cases, especially use cases with high throughput, low latency requirements. And so when we think about building a workflow engine for that sort of use case, you need to do some things differently. To talk briefly about specifics, in Zeebe's case, no longer have a requirement for a relational database for storing workflow state. So state for active workflow instances is stored on the same machines that are running Zeebe. This makes it relatively easy to scale Zeebe horizontally on commodity hardware, be it AWS or Google Cloud or on-premises machines that you manage yourself. Made a number of other design decisions to make sure that Zeebe could do what it needed to do in sort of latency critical scenarios. And so if you think about Zeebe, maybe build your mental model of it, some key points to consider, some of which we're going to demonstrate for you today. Of course, Zeebe still executes BPMN models. We've said over and over the show that we think that BPMN is the standard of the future, and for emerging use cases as well, perfect way to bring together business and development and technical operations teams. Building Zeebe to be language agnostic, meaning that you shouldn't have to make any hard decisions about the programming language you use to build your services if you want to work with Zeebe. So the same survey that we've referenced a couple of times today, we asked what languages users were building their applications with, and of course we saw a lot of Java. We also saw JavaScript, and we saw C# and Python and Ruby and Go. So we want to make sure that Zeebe can support applications built in any language. Have already mentioned scalability and performance, and I'm going to not say much more about that because part of the hacking today will sort of show you in a, I guess, more real way, how Zeebe scales and the way we approach that. And lastly, I think that Zeebe should play well with others, which means that it should fit seamlessly into a modern architecture and should be easy to use Zeebe alongside other components. For instance, Apache Kafka, if you use that for communication between services. We're going to show you a bit about that today too. Or maybe you want to use Zeebe with Kubernetes for container orchestration. But anyway, not going to give much more of an intro because I want to be able to sort of show you what these things mean in practice. So I'm going to hand the stage over to my colleagues and do some demoing. So thank you.
Thank you so much. So let's switch that over. I have not much slides actually, so I want to really dive into a bit of a demo, and it's actually diving into the code from what I talked earlier on in the keynote. So I want to make it much more concrete, and the code is available on GitHub, so you can play around with that yourself. So the first thing I want to show you, I hope you remember that from the morning. That how to track the flow. And I used the example I had using Kafka. Who's using Kafka here in the room? Okay, not that. RabbitMQ, somebody? Something comparable, whatever it is, messaging, eventing, okay? Not that much people, okay? But that's currently quite a hype topic, and I'm also, for example, I'm talking at the Kafka Summit next month in San Francisco, and we see quite a growing demand in this kind of architecture. So you have that event-driven architecture, you have it on Kafka, and then in order to track something, the easiest way is to attach Zeebe to it. And what I do in the demo, I use something called Kafka Connect. So Kafka has these connector architecture that's called Kafka Connect, and then you can easily build connectors that, for example, stream data in a JDBC way to a database, all these kind of things. And what I do is I basically stream all the events I get from Kafka into Zeebe, and then Kafka Connect checks, okay, is this event something that correlates to a workflow instance in Zeebe or not? If not, it's just ignored. That's the way I build it. You probably want to build it differently, but if it's not correlated, it's ignored. Otherwise, it probably kicks off a workflow instance, or it continues an existing workflow instance via some correlation mechanisms. And that's the first thing I actually want to show. So the first thing you probably notice, that's a cool thing about microservices. I now have a lot of these terminal windows there. I'm actually not sure if you can read it in the back, probably not. So I have everything that's on the slide. So I have the shipping service, the payment service, the inventory service. I have Kafka and Zookeeper, that's here, and a couple of other things we probably need later on. And first of all, I do a completely choreographed approach, and I want to show you how that goes. So what I have here is I have that order example, and if you saw other talks from me, you know that as a business example, I currently use oh, sorry, I didn't want to click yet, but I did. Anyway. It's normally, that's the tension, like, oh, what happens if he clicks? But sorry for that. The business story behind it's like Amazon dash button. Like you have the dash button, you just click it, and then something is ordered. And that's the story behind. So I can click that button, and now I have these services, and what you can see, that's a simple HTML application. I'm using WebSockets, so I basically just consume all the events I see on the bus and show them here. That's all it does, so I can see what's going on inside of Kafka. So I had the order placed event. That's actually what's put on Kafka when I hit the button. I have some data attached to that. And then the payment, the choreographed payment service picks that up that I had in the keynote and does something with it, and then it says, oh, I received the payment. And what you can already see in this kind of thing, because we now having that event chain, is that because we don't have any data flow from order placed to, for example, like fetching the goods or shipping the goods, at least how I build it, I actually have a lot of data in these kind of events. So I still basically carry around all the data I need in the next step, and so on and so forth. Okay, so this is a bit how it works. If you look at that from a coding perspective, probably not that, don't want to spend too much time on it, but it's a quick look, it's interesting. So what I have basically, everything here is Spring Boot. I have a couple of these services also in Golang or in Node, or I'm currently also working on C#, so that actually doesn't matter much. But I have, in this case, Spring Boot applications, and then what I do, for example, is that this is the payment, the choreographed payment service, and this listens to certain orders, events on the bus, and it selects certain events which are interesting for that service. In this case, it's the order placed event. So that's already the first part in the code where we really see how the coupling is done. So now the payment service knows something about order placed. For me, that's already the first really weird smell here, because if you now have to retrieve payment for different things, you end up with listening to a lot of events which the payment service should never take care of. So in your microservice architectures, some new component is popping up and says, hey, we need payment. You have to go to the payment team and say, so please listen to that event in order to retrieve payment then. That's a bad thing. That's a three-legged race. So that's kind of the first bad smell. And then if you go through it, you also see other things like now I have to basically also calculate like the total sum myself, because I just get a bunch of items. So what payment do I have to receive? So a lot of business logic goes in here which shouldn't be there. That's like the short message. You can read through the code probably yourself. But it's what we see out there actually pretty often. So it's kind of a reality in these event-driven systems. So the first step, if I want to go to that picture, so that was the left part of it. But now I want to connect Zeebe in order to see something. And let's go here. I have a bunch of batch files on Windows, so it's batch files. What I can do is, first of all, I can start Zeebe. I start Zeebe. What's Zeebe? Zeebe, it's basically, you can download it as a zip file, you unzip it, and then you just run the broker. That's it. So this is how you also approach it. So it's not like embedded in your own Spring Boot application, what we can, for example, do with Camunda BPM. It's a separate thing. You can also run it as a Docker image or whatever. So it's a broker. Now it's there. So I can connect to that broker. The second thing I want to do is I want to deploy a workflow model, which I'll probably show you here quickly. So there, I have a BPMN file. You're probably, I don't ask who knows BPMN, right? So it's probably all of you, I hope. So that's a BPMN file you know from earlier. I deploy that to Zeebe. Let's quickly do that. Where we are there, I deploy that. I do it via a quick Java application, so that takes a bit, but we also have a command line file, so a command line tool for Zeebe, so that's would be probably a bit quicker, so there's deployed. Now we have what we call a simple monitor, so there's a small application you can start up, and then you can connect to the Zeebe broker in order to see what's going on in the system. For example, I can check which workflows I deployed, so there's my order tracking workflow, and I don't have any running instances yet, so that's kind of not surprising. So not much is going on my broker. But the next thing I do, and that's probably interesting, I now can start Kafka Connect. And Kafka Connect, so there's I've written like a POC thing, like an own Kafka connector to connect to Zeebe, and I just configure that. So if I look at Kafka Connect, I have this thing here, and I connect it in a way that I could say, okay, I connect to my Zeebe broker, and every message in that topic, or in the message queue if you're Rabbit or whatever, should be correlated to Zeebe, and then I give a couple of information how it's correlated. So that's probably not the only way of doing it, but that was my way of doing it. So I look in the payload of the message. In my case, that's JSON, and that's JSON path. So I expect some trace ID to be part of that JSON message, and I use that to correlate the message to Zeebe, and I also check which message it is. Does it have a name or something like that? So that's actually the important part. So I just configure that sync, and then I can start my Kafka Connect. Let's do that. Where is it? Kafka Connect. Kafka Connect, this is in a way that now that's apart from Kafka. That's normal, don't worry. It's intended to be that way. Kafka Connect starts a couple of workers, so you can scale up these workers. So that's part of Kafka, that's not part of Zeebe. So whenever you have a connector, all the infrastructure from Kafka is in place in there. And what you can already see is that you have a couple of messages picked up by Kafka. So I do pretty much system out print line for that, so that's awesome. So we see the messages here. And what you can also see is that I now have an instance also running in Zeebe. So it really correlated everything. And what you probably, I'm not sure if you recognize that, but what I did is I played it back. So I didn't do a new order, but Kafka keeps a history of the events. So it catched up. with the old events because it hasn't yet processed it. If I do that again, like this, another order, then I have order 2. If I now refresh that, it's automatically in Zeebe. And that's part of the story I had in the morning. So now I have tracking in place, and now I can start to add stuff like timers to do something like escalations, or what we heard with the Vodafone story earlier on, probably even go into a migration project. So that's a cool first step. And the good thing is, apart from all the microservices I have here in Spring Boot, I haven't yet touched a line of Java, actually. So I could deploy the model. I could use something like Kafka Connect. It's not like yet the production ready out of the box connector, but it's not hard to envision that. And it just works. So that's the first step. But I still have these choreographed services, which I already discussed that this is probably not where I want to end up with. So let's quickly change that. So first of all, I shut down the Kafka Connect. I shut down all these choreographed services because I'm not a big fan of them, so let's just kill them. So that's it. So easy it is to change architectures. So it's gone. Now I actually do one thing which I don't want to explain in detail, so I don't do it. Now I want to start the orchestrated services, actually. And the first service I want to start there is the order service. And that's actually, if we go quickly back to the slides, so we're leaving that scenario towards the manage the flow thing. And what I have now is basically I have Zeebe already running, so I haven't shut it down, so it's still there. I now have my order service. That's the one I just start up. And the order service now uses that Zeebe, that BPMN workflow we saw earlier on, where we still react on the messages, like from checkout. So probably you haven't seen that, but I haven't shut down the checkout service at all. So the checkout service is still the same. It still produces the same message, but now I have a different, like a new order service. And that means whenever this should be up, it should deploy its own workflow. So now there it is. So that's the other one. And I don't have anything in here yet, but if I go to put another order there, it's now picked up by the order service, and that means this order Kafka thing is started. And one thing it did is like the first thing that it does, it commands the payment to retrieve something. And I can even see that on the other monitor I had earlier on. So I had the order placed event that's picked up, that's on Kafka, it's picked up by Zeebe, and Zeebe says the first thing I want to do is retrieve the payment. So that's a command. And now the payment service is missing. I still have to actually start the payment service. So whenever this payment service comes up, it finds the commands in the inbox, and whenever it's up, it will process it and says, okay, hey, we're having the payment received, and the next step is the fetch goods. So that's, again, from the Zeebe workflow. So we are moving, or we are advancing here in that workflow, and so on and so forth. So that's basically what you can do, and you can basically have all shades of gray in the middle, like monitoring events, tracking events for certain parts of the thing, escalating, doing some kind of commanding. So that's kind of a part of the puzzle. Let's quickly jump to the code. Where is it? There. So what I have is actually by intention, because I wanted to show you a bit of the Zeebe API, a bit of Java. Who's speaking Java, writing Java fluently? Okay, that's more than half of the audience. I do it in Java today. So what I could have done, probably to say that first, I could again have used something like Kafka Connect in order to say whenever I have the send message event in a BPMN process, I want to really send a message to Kafka, and then it moves on. Then I probably could do the same thing without writing Java code. That's probably possible, but I actually preferred writing Java code in this case to do a couple of things and also to show how Zeebe is used. So I have that order service, which uses Zeebe. So I have a dependency on the Zeebe client, and one thing that changes to what you can do with a Camunda BPM. So Zeebe is really a separate broker. We just connect to it. And, and this you could envision something like this. So I just have a Zeebe client, I connect to something, to an endpoint, to the broker, then I have my Zeebe client, and then, for example, I can deploy something, so I have a workflow client, deploy something, hey, this BPMN, please deploy it on Zeebe. Then we have a completely asynchronous API, so that's what we get back as a future, so we don't have to wait for that to complete, but you can wait for that to complete, and then we move on. And then we have a message listener again, where we, in this case, listen to, again, Kafka messages. So what I do is I say, whenever there's an order placed event on Kafka, I go in that message. I read probably some payload. I probably do the additional business logic, which is one of the reasons you might still want to write an own service for that. But then the next thing we do is we just kick off a new workflow instance in Zeebe. So this is how it looks like. Like we have a workflow client, we create a new instance, we have this BPMN process to start, please start it in the latest version, attach some payload. The payload is always a JSON, so that's also different to Camunda BPM, and then same thing, I send something, and then I can wait for it or not. I can decide if I want to block for it or not. And then it goes on, like, if I get the payment received message, it's basically the same thing, but this time I say, okay, there was a new message, so I publish that to Zeebe as well. I say, which message do I have? What's the correlation key? So that's the trace ID had earlier on, probably some payload, and then the same thing. So what you can see is it's relatively easy what I do here, and you can easily imagine this kind of code. Is it readable in the back? Yes, awesome, good. Haven't asked that because it looks a bit small there. So you could easily envision this this type of code to be generic. I just like writing it line by line in this kind of example to really understand what's going on there. And then it just goes on like this. So that's basically the part where we have Zeebe inside of the order service. And as you see, it's a remote connection to Zeebe. So if you have, like, in payment, you have an additional BPMN workflow, you could still deploy it to the same Zeebe instance if you like. So that's part of the discussion we had in the morning as well. OK, that's this. And one last thing, which is probably interesting, which I coded a bit in this monitor. So that monitor is it's also like a small Spring Boot application. It's completely homegrown. I just written that, and I also written the HTML code to do that on the JavaScript code. But I added this link, and this link visualizes the idea I also had on the slide in the morning, like what I can easily do. In this case, I used the BPMN model, even a collaboration model, which is just a drawing. So it's not a model which is executed anywhere. It's just a drawing. But I used BPMN.io, and it's like 10 lines of code. If you have the events somewhere, like in Elastic, or in this case, I just collect them there, like I show it in the list. So I have the events. And then I say, if like order placed event is the name of some activity or some event within the BPMN model, I make that tick. So that's very easy. But it visualizes the idea that you can have kind of a joint monitoring for these even like these various services. And what I could even now I can decide also on the granularity which kind of events I want to show in this kind of model. And I think it's an important part of that vision of having these like really decentralized engine, really these kind of architectures. That would be basically all I have for the moment. So I would hand over to the really awesome demo, which I'm looking forward to a lot. By Felix. Thank you, guys.
The laptops. Just bear 1 second with me. I just have to connect my laptop here. Let's see if that works. I also want to go to...
Take a bit, or is that ready?
No, it's almost ready.
Okay, otherwise we could do crash.
Let's just trying to use Wi-Fi as well, which might be a little bit challenging. So let's see how well that works. Okay, so now we have seen a lot how you can use Zeebe locally, how you develop a little bit, and the different concepts, how Zeebe could be used in the different scenarios. What I still wanted to show is how well Zeebe actually can scale. So the title of this presentation is more or less workflow automation at scale. So you're probably looking for numbers or something like this. That's why you joined, maybe. What I try to do now next, if the internet works correctly, you can see here I started on AWS in the cloud some instances. So we have about 60 servers, I think, that are running here. Maybe not completely 60. We also have 59 servers more or less. And they're running now in the cloud for a while, and on about 35 of them, I have a Zeebe broker installed, and this builds more or less a cluster in the cloud at the moment. And on top of that, we have about 20 instances or so that are responsible for starting workflow instances. What does it mean, starting workflow instances? When we look at the BPMN model, so I think I have here a Zeebe model open. So starting an instance from what I'm measuring now is from the start event more or less till the first service task that would execute some business logic. And we want to see how many of these instances can we start per second. So let's go here. I have also prepared, hope you can see that in the back. Played around with it a little bit. So what I did is, this is also on GitHub. I can share the URL later if you want to test it out on your own cloud environment. I have some Terraform scripts that set up all these instances automatically on the cloud. And then I have some Ansible scripts that are responsible more or less for setting up Zeebe as in the cluster, the different brokers on all the environments, doing that, and also these Java clients, something similar that Bernd just had in his talk, that are responsible for starting these instances. And what I will try to do now is I will try to start the whole thing. So this, I'm using Ansible now that connects to the cloud, and it will try to get the different services that we have at the moment. Yeah, might take a little bit. Meanwhile, I can show you something else. So I have locally, if that works, okay. That doesn't work. That should work. I have in Docker, I have at the moment some monitoring environment also running. So I have Prometheus and Grafana running locally on my machine. And I have this running with Docker. That should in general work. Let's see if I can bring it back up. Okay, there are some errors, which is not so nice. I will just quickly put that down and restart Docker. It was because of the restart. My Docker has some issues. Let's give it a few seconds. Meanwhile, we can check what our instances are doing. You can see now what Ansible is doing is it gets all these AWS instances and knows it's in dynamic inventory, and it knows now where it should restart or start more or less the workers that start these instances. And because we have slow internet that takes so long, usually it would be very quick. So next step that it's doing now, it's stopping everything just to make sure that we have really the correct numbers. Meanwhile, we can see that Docker is up again. So let's hope for the best, and we're going to start this thing again. This looks better. So let's see. Oh, Grafana's up. That's a good sign. Okay. This looks already better. Let's see. Getting no events at the moment. So this is still stopping the instances at the moment. Everyone should switch off the Wi-Fi on their phones and so on, and then it's going to improve probably. Yeah, sure.
While we wait, shall we break the...
Maybe we can get the microphone as well. Let's see.
microphone is dead.
Oh, Nadine has the microphone. Just 1 second.
Oh, it's a microphone. I thought it was the square thing. Okay. Oh, okay, there you go. Okay, so basically my question is to that guy, because I see him developing stuff. So use Zeebe. you use Zeebe pretty much to orchestrate the interactions, but you didn't use, like, for instance, in Camunda, you do a lot of setup in the BPMN. The BPMN was pretty much like the drawing. Pretty much all the stuff was done in Java, and the drawing was just for the sake of, you know, controlling the events and stuff like that, or did you actually did any setup in the BPMN, any configuration?
I haven't shown like everything in there. Am I on? Yeah, okay. I haven't shown everything in there, so there is a bit of configuration in the BPMN file. So for example, like if I have like the message name, for example, I want to correlate to, and also some correlation rule I use in order to correlate, and also like if I have these kind of service tasks where I want to send something, I actually forgot to show that, to be honest. You also configure it and connect it to code. So there's some configuration in the BPMN file. And yeah, does that answer the question?
Yeah, pretty much. Like, but you created that message listener application. Was that was a Spring Boot application,
yeah.
right?
Yeah.
Okay, so that routing of the messages you did in that application.
Yes.
That okay.
Yeah. Yeah.
Okay.
So it depends on how you want to really lay it out in your architecture, but I think it's very realistic if you think of in terms of I'm doing that order microservice, because that's not only like routing the different things like payment and inventory and orchestrating that, but it normally does additional stuff like storing the order or probably calculating a couple of things. And so then it's really realistic to have this kind of setup. You could, that's what I meant, you could also run it in a way completely without Java if you like. If you have stuff like Kafka Connect, so, but that depends very much on the architecture you want to go into.
Yeah. So, yeah. I still want to wait a few more minutes. That's why I want to ask
yeah,
one more
okay,
question that is
awesome.
around here at the moment. I have a backup, so don't worry. But I still want to see that live. So I'm still hoping for, because we still have a few minutes left.
For the Wi-Fi?
Yeah, I'm using my mobile hotspot now. Maybe it works better. Let's see. So
luck.
one question that was around is how many BPMN symbols does Zeebe support at the moment and will support in the future?
Shall I take that, or do you want to take that? I should take that. Okay, currently we're, you pretty much saw most of what we have, not everything. So we have that service task, we have the message receive event, so message correlation, we have parallel gateway, we have XOR gateway, so we can decide. So that's the current, and we have sub-processes, I think, pretty new. Yeah, we do. So that's what we currently have. We are extending that relatively quickly to a couple of more things. Like what is it? I forgot. Timer. What is that? Yeah, timer. That's what I said. Yeah. Like boundary events. A couple of things there. I forgot the exact roadmap, to be honest. But we're having a lot of things piling up for. Let's say we're talking about the next 2 quarters. So it's not like the next 2 years. So it will be relatively quick that we get to broader support of BPMN there.
Okay, thanks. And when would you say that Zeebe will be production ready?
So we currently aim for, let's say, beginning of next year. So that's what our current goal is. It will not be in really like Camunda BPM, like a full-fledged product, which is like you can license easily and these kind of things. So we're going really focused into certain customer scenarios, and we want to also support it there in their scenario beginning of next year. So then when we put the first things into production. So.
Perfect, thanks. So it seems that this doesn't really work with the internet.
Internet, yeah.
I don't want to try harder, so I did that obviously yesterday evening as well at home. You can see that is yesterday, 20th of September. I tried it at home and it worked. And what do these graphs show you more or less? I was also connected to the same cloud that I tried to set up now. Didn't work live, unfortunately. And you can see we have a number of brokers that this thing is connected to. We have the whole cluster, more or less. So you can see on the top right, like file system, what is going on each server, how much data is written, more or less, and read as well. And then the most important thing is the top left here. And this information shows you how many workflow instances were started per second. And we can see here that we were there around 800,000 new started workflow instances per second. And you can also see that it is quite stable. So this is a very, very large number for us. We have heard downstairs already today big numbers regarding Camunda BPM, but we still believe that this is at a different scale and different level as well. In earlier tests, I was also more than 1 million was possible. That was always the aim. I also hoped for it today, but that's fine. Another number that is important is the number of events that we are processing. Why is this number relevant? Because we can compare from the performance to systems like Kafka, for example. And we talked a lot about Kafka as well. You have shown these Kafka Connect things. And it's obviously important that if Kafka is super fast, we have to be super fast as well in order to be able to process these events. And this is what it shows you. So I hope you believe me that these numbers are true, also without the internet, and that's fine, I guess.
That's distributed systems.
That's how it is. This is how it works in conferences. Many
it's
people
probably there, but probably not.
Exactly. Okay, let's see.
We have to the questions.
We have a few more minutes. So
there was one follow-up on the BPMN support of Zeebe. Is there error handling? And I forgot about error handling. We're targeting error pretty soon as well, of course. Do you want to take over?
Yeah, there's one question regarding the event history, if it's an obstacle to scalability. So would you say, because we have all that history and we can also use things like Optimize, for example, to build reporting based on this data, but doesn't that mean that we have problems?
And I think that's also probably even related to the question, so how does it scale better than the current workflow engine, which is kind of, we haven't yet talked about how it's built. Which I would have a slide, but I think that takes too long. So the basic idea is that we really, Zeebe is built from ground up differently than the Camunda engine. So we don't use a relational database underneath. We're getting like an event stream into the engine, and then we have a couple of so-called stream processors, which look at these events and these, or records we call them, because it could also be a command like start a new workflow instance, could be a command I sent in, and then there's a workflow, a stream processor which says, okay, I'm caring about workflow instances, okay, I start something, and we just keep, let's say, a snapshot of the current state on that thing, but we don't write it to any database, but we basically rely on that event stream to happen. And then it's quite abstract without a picture, I think. And then the second important thing is that we have that Zeebe broker, and that Zeebe broker, it stores the events, for example, on disk, just on disk, because we store it on that machine. But then we have an own distributed system, so there might be the second broker, or in your case, was like 30 brokers or 40 brokers. Then they replicate the data amongst these brokers, and that makes it easy to always shut one broker down. The data is still somewhere else, and there we use a lot of these algorithms which are quite known in distributed systems, also what Kafka does, like we have a single writer principle, we have the RAF protocol, we have consensus, or a couple of things in order to make that happen, to really get to this scalability thing. And I think that's the important thing. We're pretty fast, that's cool, but we're really horizontally scalable, and that's the important part of that story.
So if you say Zeebe is so cool, would you say that it's going to replace Camunda BPM, the workflow engine?
I don't think so, not in the foreseeable future. So I mean, relational databases are also still around for a good reason, and we're having quite an adoption of Camunda BPM, and for the use cases I see 99% of our customers doing Camunda BPM is fine and will be fine for quite a long time. Zeebe is really for new use cases, quite for high frequency, and also probably for cloud native scenarios if you don't want to have a relational database for whatever reason. And that's currently it's a separated base, and let's see how that evolves. But currently I don't see that replacing Camunda BPM.
Okay, perfect. Thanks.
Thanks, guys.